today we're looking at some particular patterns that occur when you start multiplying binomials together. If you remember rightly, binomials are polynomials that have two terms. And if you start multiplying polynomials together, you get bigger and bigger polynomials. But there are certain patterns that can help speed up your calculations. A classic one is a plus b squared. If you multiply a plus b times a plus b, you always get a very regular pattern. You would get a times a gives you a squared, a times b gives you ab, and then you also get ab again from the middle terms. The outside gives you ab, the inside gives you ab, so you end up with 2ab, and right at the end you get b squared. And instead of a's and b's, you could have anything here. You could have letters, numbers, combinations of different variables, but if you have this pattern, you can quickly jump straight to the answer like this. A similar thing happens with a minus b squared. You're going to get an a squared at the front, definitely. At the back you get minus b times minus b, which gives you plus b squared, so it follows the same pattern as this. In the middle you get a times minus b, which is minus ab, and in the middle you get minus b times a, which is the same, minus ab. So you always get minus 2ab in the middle. But you do get plus b squared because you have the two negatives making a positive at the end there. So these two patterns are very similar. This one gives you a minus 2ab, this one gives you a plus 2ab. And if you're aware of these, it means you can speed up your calculations. You don't have to think this through every time, which is especially useful if you have like more than just an a here, which I'll show you in a second. A plus b cubed also has a pattern, but it's less simple to work out straight away. What this would give you would be a plus b times a plus b times a plus b. So effectively, you can think of this as a plus b times a plus b squared, which we now know is this. And if you multiply out those brackets, you get a times a squared is a cubed. Then you get an a times 2ab, which gives you 2a squared b. Later on, you have a b times a squared, which gives you 1a squared b. So the 2a squared b and the 1a squared b gives you 3a squared b. And the same sort of thing happens when you start multiplying the 2ab by b, you get 2ab squared. And you also get b squared times a gives you an ab squared. So you end up with an extra 3ab squared. And at the back you have a b cubed. So you definitely have an a cubed and a b cubed, just like before we had an a squared and a b squared. But in the middle you have an a squared b and you have an ab squared. And you end up with 3 of those and 3 of those. Similarly, if you're doing the one involving a minus b, you are multiplying effectively a minus b times the answer from the a minus b squared up here. And you end up with a solution. For the a minus b cubed, you have in a similar way an a cubed appearing from the front. At the back you have a minus b times b squared, so you get a minus b cubed. And in the middle you do get 3's, but the first one, where you have an a times an a here giving you a squared, and an a squared here and a minus b here, you always get something which is negative, so you get minus 3a squared b. But the ab squared that comes from this one times this one, and this one times this one are both positive, so you get a plus 3ab squared. So this pattern looks a lot like this, but it has 1 plus and 1 minus. Lastly, it's worth talking about one that's a classic that you've come across before. This is the difference of two squares. If you have an a plus b times an a minus b, you always end up with a squared minus ab plus ab and then minus b squared. And so the bits in the middle cancel each other out. So you get a squared minus b squared. And that means part of the reason we do this is that if you can spot these patterns, that means you can factorize them back into the brackets later on. Okay, let's have a look at some examples. So this here is something take away something all squared. So it's following the pattern of a minus b all squared, which has the pattern a squared minus 2ab plus b squared. Here, instead of an a, we've got 2x, and instead of a b, we have 4y. But we can use this pattern to help us simplify this expression. And we would have something which would be 2x all squared minus 2 times 2x, which is our a, and then the 4y, which is our b, and right at the back we've got plus 4y all squared. I've just used this formula and replaced every single a with my 2x and every single b with my 4y. We don't need to use that minus involved with the 4y because the minus is the same in this expression as it is in this expression, and we're using this pattern from this a minus b. But I can go through and simplify this. 2x squared is 4x squared. 2 times 2x would give me 4x. I've still got to multiply that by 4y. At the back, 4y all squared would give me 16y squared. And just to tidy up the bit in the middle, I would have minus 4x times 4y would give me minus 16xy plus the 16y squared at the end. And so this pattern helps us just to quickly put things in the right place, simplify it, get your answer. So here we have 3x minus y all cubed. So this is going to follow the pattern of a minus b all cubed. And the pattern for that one is to have a cubed minus 3a squared b plus 3ab squared minus b cubed. Putting everything in the right place, instead of a I have 3x, instead of b I have y, I would have 3x all cubed minus 3 times 3x all squared times my y plus 3 times 3x times y squared, and right at the end minus y cubed. Again, I've just gone through this formula and replaced every single a with my a and every single b with my b, and then I go through and simplify. 3x all cubed would give me 3x times 3x times 3x, which is 27x cubed. Here I've got minus 3 times 3x all squared. So that 3x all squared is 9x squared. 3 times 9 is 27. So I've got minus 27x squared y. Now be careful with this. It's not 3 times 3 you have to do here. It's 3 squared first. You have to do the powers first. Here, there's no powers on that brackets, so I can just do 3 times 3x. So that gives me plus 9xy squared minus the y cubed right at the end. So you slowly work your way through and you fill in what the individual a's and b's are from your question, and then you go through and you simplify it afterwards. And again, take your time. There's no rush with this. I would rather have it correct than rushed and all wrong, especially when there's minus signs involved. You've got to be careful. It's worth making a note of these 4 formulas. These formulas can help speed things up. This is a plus b squared, you get this pattern. A minus b squared, you get this pattern. A plus b cubed and a minus b cubed give you these patterns. And these patterns help you to simplify more complicated solutions. So there's some work for you to do. Good luck.